Station 2 possesses three different objectives: testing the conductivity of dry samples of the solid, determining the solubility of each substance in water, and testing the conductivity of aqueous samples. In order to test the conductivity of the dry samples, my group placed each sample into a plate with small half-spherical depressions. After this, a group member placed an electrode into each depression to measure the conductivity. This resulted in zinc being the only conductive solid. Zinc is a metallic solid, which means it has a relatively high melting point. It is insoluble in water, it is relatively hard, and it conducts in solid form. In this experiment, my group placed several drops of water into each depression, then mixed in the substances with a toothpick in order to discover if the solids dissolve. The only solids that would dissolve were potassium iodide, table salt, and sucrose. Sucrose is a covalent solid, suggesting that it has a low melting point, low hardness, it is non-conductive, and only soluble if the molecule is polar. In this case, sucrose is polar, therefore making it soluble in water. The objective of the third and final part of Station 2 was to test the conductivity of the aqueous samples. Both table salt and potassium iodide were conductive when dissolved in water, but sucrose was not. Both potassium iodide and table salt are ionic solids. Ionic solids have high melting points, most are soluble, they are hard and are only conductive when in water or when they are in the molten phase.